Thank you, sir.
Hi, yes, sir. Expert is joining within 2 minutes.
Okay, okay.
Yeah,
So,
so
good evening, everyone. Before that, a small announcement is there. So, tomorrow session is going to be started. Last session 2 to 5. Immediately after the session, valedictory followed by quiz compulsory. Minimum you need to get the 60% marks in the quiz, and already we are tracking attendance every day. So, from that we are going to consider 80% attendance. So 2 to 5 compulsory. Please make a note of that and try to attend 2 to 5 compulsory session. Valedictory followed by quiz.
Okay. Yes, sir.
Hello, everyone.
yes. Hello, Sainik sir.
Hello, Dangi sir.
Good evening, Senik sir.
Good evening. Good
Yeah,
evening.
yeah. Welcome, sir, for this today's session.
Thank you. Sorry, took me a little while to log in. Some password issues as usual.
Yeah, yeah. Okay. So we will start now. So yes, Unnati, are you there? So just start with the.
Yes. Okay. So, good evening, everyone. I hope you all are doing well. I am Unnati Dabhade, student of third year computer department. I warmly welcome you all to the day 4 of our 5-day online faculty development program on emerging trends in technology and innovation for digital transformation. Yesterday, on day 3, we explored an exciting and futuristic topic, Agentic AI. The session helped us understand how AI systems can reason, take autonomous action, and collaborate with humans and reshape modern industries. And today, on day 4, we continue our journey with the very interesting topic that is data streaming. Data streaming is a heart of real-time digital transformation. It enables instant data processing, continuous insights, and faster decision making, powering applications such as fraud detection, live analytics, IoT systems, and large-scale distributed platforms. Through today's session, we will understand how modern organizations design real-time streaming architectures and how streaming technologies are transforming global business ecosystem. I'm very happy to welcome our speaker for today, Mr. Shrenik Shah sir, software architect at Merit International, Canada. Thank you, sir, for joining us for this evening.
Thank you, Nadi. Thank you so much for the warm welcome.
I
It
also
is.
extend a warm welcome to all our respected faculty members and participants present for today's session. It is my privilege to introduce our today's esteemed speaker, Mr. Shrenik Shah sir. Sir is an accomplished software architect with extensive experience in designing and leading enterprise-grade systems across global organizations. At Marriott International, one of the world's largest hospitality chain, Sir plays a key role in architecting scalable, high-performance distributed systems, implementing real-time data streaming pipelines, designing cloud-native enterprise platform, enhancing application reliability, data flow efficiency, and system resilience. Sir has strong expertise in data streaming architectures, cloud and microservices, event-driven platform, high availability systems, system design, performance optimization. He has worked with advanced technology to modernize system workflows, improve operational efficiency, and enable real time decision making at scale. Sir is known for his deep technical knowledge and practical architectural insights and his ability to simplify complex engineering concepts for a diverse audience. We are truly honored to have him with us today. Thank you, sir.
Thank you, Unnati. Appreciate you giving a brief introduction. And once again, good evening to everyone.
And we now request you to kindly begin the session, sir. Please, sir.
Sure. Thank you so much, Unnati. So, as you said today, Unnati, we are currently looking at a kind of an era where the technology is changing rapidly. And given that fact, okay, you all have been going through a lots of various I would say technologies or paradigms or all the evolving new dimensions around computer science and related subjects to understand how systems are changing and then how it impacts day to day business operations and people's life, as well as how it impacts the way we all work. So, assuming that today is a faculty development program, let me kickstart this session with certain assumptions and certain background. So, allow me, please, I can share my screen now.
Yes, sir. Sure, sir.
Okay. Okay, so you are able to see my screen? Please let me know.
Yes, yes. It is visible.
Yes, sir.
Okay, so yes. All right, so let's get started with this exciting subject of data streaming. Unnati, you gave us a very brief introduction around, data streaming, and thanks for that. However, today I just want to set certain assumptions right before we move ahead. So, in today's data streaming session, I was actually thinking the moment Dange sir informed me that we are going to have this kind of a session and then it's a faculty development program. So my thought process was around what should be covered, what should not be covered. If you look at data streaming as a subject, it is really, really vast and it is increasing every day leaps and bounds. It all started with some basic, I would say, distributed commit log that is kind of written in LinkedIn sometime back, I would say around early 2000s. It finally came to mainstream with the big bang introduction of Apache Kafka becoming an open source project accepted over there. And then that's how, things started moving in mainstream, where a lot of organizations, systems started modeling things in and around that data streaming concepts. And of course, there is a lot to talk about. Of course, I will jump into that part. So today, what I was thinking is we will just go around understanding data streaming as a concept, and then how organizations are leveraging it, as Unnati already introduced around that. And then we will see if we have additional question answers around that. We will dive deep. And I'm happy to have additional further sessions as well whenever needed so that we can further deep dive into that one. So given the limited time today, sir, we have 2 hours, right? Today, 7 to 9 p.m., if I am correct. So within those 2 hours, I'll try to cover maximum over here. So before we start, let's take a moment to understand, okay, what comes to everyone's mind when we talk about data streaming. So I will just give you all a minute to give me your responses on slido.com. So requesting everyone, please visit slido.com and enter code 2330155. Take a moment to understand the question, and then please give your honest answer over there, which will definitely set the tone for this session. So this poll is open now. Please go to slido.com, enter code 2330155, and start sharing your responses. If anyone facing any difficulty, please let me know.
Will you please repeat the code?
2330155. It is there on the slide. Are you able to see the slide?
Yes.
Yes, sir, it is
Okay.
visible.
Slido.com, and then over there you will directly get a window to enter your code. Enter code 2330155. Good to see responses flowing in. Interesting. So the moment data streaming word comes into mind, okay, I could see good number of responses coming around. Interestingly, new algorithms for streaming online computation is currently leading, and people are also talking about hands-on industry aligned projects for students. So currently what I see is algorithms for streaming online computations is what people are thinking about when data streaming comes to mind. And that's a very interesting perspective, right? How data streaming is shaping up the industry is definitely another perspective to talk about. So good. Thank you for your responses. If anybody is still pending, please feel free to respond, and I'm continuing with the session. So given that, data streaming is being established as a de facto platform now, and data itself is being started treated as a first class citizen in our industry these days. Let's start diving a little deep into how this all evolved and what actually caused data streaming to happen at one point in time. So let's see what next over there. So first of all, let's look at little around data streaming. Okay, why data streaming and what is the motivation around data streaming? So if I try to think through data streaming, okay, traditionally, if you look at the way these systems were designed, right, many systems lived comfortably within that batch processing era. And I'm sure, being faculties, you all are aware of nuances around this. Okay, run a job at midnight, generate a report, make decisions hours or days later. That's how these batch systems used to run. The real time user experiences were very less at that point in time. And of course, the surrounding infrastructure also plays a big role. We are going to look into that in the upcoming slide. But like today's date, if you see modern applications like fraud detection, ride hailing, we see, right, Ubers, Lyft, etc., then real time recommendations, they simply can't wait in today's era. Data is flowing continuously everywhere in real time. It is happening. There is a popular word in industry today which is known as data in motion, whereas the past was very popular with data at rest. Whenever you design any architecture, whenever you design any systems, people will start talking about data at rest. What are you doing with data at rest? Is it encrypted? Is it safe? How are you going to process that data? It is in lake house, it is in data warehouse, it is in data lake. And then what exactly is happening with the data at rest? That used to be the buzzwords. But slowly, industry is moving towards that paradigms where everybody understands now organizations are flooded with continuous data. be it application logs, be it click streams, be it IoT devices, mobile applications. So this also pushes everything forward to low latency responses, low latency decisions over continuous data. And that is what is leading us to data streaming. So if you look at it from that perspective, right, I would just simply, a peep little bit into your mind. You all already know streams, but it's just in bits and pieces. Assuming you all are faculties, right? You all have been teaching streams in some or the other way, but not as a stream paradigm. You are teaching them in operating systems as IO streams or pipes. In network, we talk about packet streams and flows, right? Then in DBMS, we often mention logs and replication as a kind of stream. Also in programming languages, especially Java, Node, Go, we talk about input-output streams and synchronous streams over there as well. Similarly, in data streaming platforms like Kafka or Flink, to bring in this perspective, right? We bring these ideas together into a coherent platform and abstract wherever it is naturally treated as a time-ordered stream of events. So data streaming, if you correlate with these subjects that you already have been familiar with, one point in time, they all will build a foundation block of modern day data streaming that we are looking at. And that is how stream is not a new animal as such. We all have been kind of accustomed with it in some other form, but there are certain developments which happened in few recent years which actually made stream make general, make scalable, and then make error free or fault tolerance, and then become a mainstream thing. Otherwise those were focused in the vertical domains. So let's see how this all evolved over the period of time, right? So earlier, we know that technology was evolving continuously over the period of last few decades. And if we look a little bit behind in the recent past, okay, when mainframes got introduced in 1951, that was one of the biggest breakthrough of the technology evolution that we all have witnessed as a human mankind, right? And at that point in time, when commercial digital computing started with the introduction of mainframes, okay, analytical data or the batch processing was also introduced into the mainstream. Because of the computing power available and in your hand, slowly, okay, data started flowing in and then started residing into mainframes. And of course, this data was always historic data, let's call it that way. And that historic data was lying in your software, in your storages. And then there used to run, batch jobs, nightly batch jobs, or let's say daily, weekly kind of batch jobs, which will actually process that data and derive analytical decisions out of that. It started in 1950s and it got introduced, and in till date today, okay, many organizations are still running that mainframe. I'll come to that part. Now, let's look at client server paradigms evolution, right? So in 1981, once IBM PC became mainstream, okay, that desktop started reaching every home. Suddenly, that paradigm shifted. Once upon a time, data used to live on mainframes into a central location. And now what we see is every desktop started containing, or every PC started having a kind of a data store on their local disk. And that give literally a parallel paradigm started evolving, okay? Client server programming was kind of a thing at that point in time. Databases used to behave like, mini servers available on your local disk, and then software will interact with that. And people started focusing on a programming paradigm as well, which was actually giving them that kind of a notion, and then deal with the data available locally on the disks. Later in 1990s, when internet evolution breakthrough, this further got evolved into three-tier paradigms where true client-server and database kind of applications started emerging on the horizon. And now imagine in 2007 when smartphone got really introduced. 2007 was the year when Apple actually introduced iPhone. And the technology or the device, computing device, actually become mainstream in true sense. How? Earlier, if you think about 1950s or 80s or 90s, that era, or let's call it pre-2000 era, can you imagine how many of our familiar people, like our parents, our families, our relatives, were actually exposed to computer systems? Maybe very few. Why? Because at that time systems were confined within the boundaries of offices, okay, and banking institutions, for that matter, who were the early adopter of these computer systems, they are the ones who used to generate a lot of data. Then if we look at other corporate dimensions where let's say uh, uh, for example, any corporate which basically heavily invests in technology, they started generating a lot of data, and then slowly at that point in time, data warehouse and then other dimensions kind of become mainstream. Everybody started using it in a big way, and any computer science professional who is actually working in some or the other corporation will be eventually coming across this terms as client server, database, three-tier paradigms, as well as data warehouse and that kind of things. But the moment 2007 onwards, when smartphones actually became a true smartphone, actually became available to mainstream, slowly that proliferation of technology started, and it started going to every home. And imagine our grandparents who were never exposed to computer systems. Suddenly, today, you see them, they are also generating a lot of data and dealing with that. Most of them in real time as well, and we don't even realize. We will correlate that. But what I'm trying to point here is that once upon a time, data was consolidated within the walls of mainframes. Slowly, it started reaching every home, and then it started reaching every person's phone by the time this technology evolved. So what happened is we had three major technology evolution breakthroughs during these time frames. Okay, mainframe was once upon a time. It is still lingering around. It is still having its own way of looking at technology and its related paradigms. PC desktops, they are still there, and they are going to be there for some time. However, I'm hiding mobile behind another technology evolution called cloud computing. So when we look at this proliferation of technology all around, cloud computing was another breakthrough which started pushing all the technologies to its limits. And remember, once again, we are still discussing data streaming, where in the fundamental it lies basically that there is fundamentally data is lying under it, right? So think, I want all of us to think in these dimensions, that when mainframes were there, how data was being dealt with. When desktops were there, how data was being dealt with. And now, when cloud computing got evolved, how data is being dealt with. So, evolution of data processing, that streaming kind of concept, if we try to arrive at right now, okay, this timeline actually helps us position streaming properly. So initially there used to be OLTP and RDMS, which gave us transactions in consistent state, but reporting was often offline. Then data warehouses and ETL consolidated data centrally, okay, but refresh cycles were slow. So as we started moving from 1970s to 1990s and 2000s onwards, okay, slowly late 2000s, the way internet started reaching everywhere, okay, big data and batch analytics kind of started becoming mainstream. And the big data era actually introduced Hadoop and Spark kind of systems for large scale batch analytics. I'm sure this must be one of the subjects in the curriculums that you all are teaching. But if you are able to correlate, slowly this led to kind of a need arising for near real-time log aggregation and complex event processing. And today, if you see, that has further evolved into data streaming as a core paradigm. How it all evolved, let's take a quick look at this. There was an age of bureaucracy where, if you see here in the picture, okay, all circles represent people within a corporation or an organization, right? Initially, business started functioning with people. Responsibilities were divided functionally. Peer-to-peer communications were happening. One-to-many communications used to be very normal. Repetitive tasks used to happen. Conversations used to happen. Example, one person who is responsible for processing order, let's say he's sitting in the center of this diagram, then somebody from finance department will come and inquire, hey, what is the status of this order? Somebody from shipping department will come and say, hey, what is the status of this order? Somebody from business department will come and say, hey, what are the total number of orders you have processed today? And so on. So people used to keep generating data at that time as well when technology was not there, but that data was being generated again and again. It was less efficient. People do not realize that they are reusing their data, they are generating data, and then again when data started becoming commodity after technology evolution, then only people started realizing that there is a value in it. So how it all started evolving? Recall that previous diagrams where I was sharing the timelines, how PC started evolving around 80s. Okay, slowly you see in this corporate ladder or in this corporate mesh, okay, computer systems started surfacing within specific departments. So sales department will have their own set of technology. Marketing department will have their own set of investments in technology. Similarly, operations, finance, product, everybody will have their own computer systems to work with. Now, what this means is PC got introduced in business, of course, but it contributed to increase in productivity and efficiency of people, not the business as a core. Why? Because data was still stored locally within these departments, within these PCs. Okay, people still used to interact with people for data exchange. Somebody from product department will go and say, hey, sales, give me a report on XYZ. And then that sales guy will actually run through his computer systems. Previously, he used to take 10 hours. Now he will produce it in, let's say, 10 minutes and then give that report copy to the product department. And then product department will still go over it physically and then take the data semantics wherever they go. And that's how data semantics were confined locally within people and data departments. Okay. Of course, when this kind of silos exist, you cannot expect a universal format where people start exchanging data and take it forward. So then slowly everybody entered into the age of cloud with the help of internet, thanks to internet, right? So when cloud started penetrating into the corporates or into, I will say, mainstream businesses, not in general to mainstream people, but mainstream businesses. At that point in time, what happened is everybody started looking into ways where they can leverage cloud. So at that time, cloud offered two critical components to people. First, a compute at disposal. What that means is that earlier CapEx was kind of seen as a company's expenditure in computer systems, and then people will start using that within their corporate boundaries. But slowly that CapEx started becoming OpEx. So if people are not familiar with CapEx and OpEx terminologies, CapEx is capital expenditure and OpEx is operational expenditure. So businesses take decisions to do capital investments at some point in time where they say, okay, we are investing, let's say, 10 crores to invest in computer systems that will modernize the way our corporate work. And when cloud started emerging, it was not a one-time capex, but it was an ongoing recurring expenses, and that's where you can say it was operational expenses. So it was OpEx. So then slowly business started thinking that instead of investing 10 crore upfront, why don't I, shift this 10 crore, break this down into, let's say, chunks of 1 lakh, and then I have 100 months of leverage where I spend 1 lakh every month and I still leverage the computing power that was available to my disposal after spending 10 crore on my premises. Rather, I will pick up cloud and I'll start investing over there. So when this happened, along with compute, okay, data storage technology also matured. Around 2006, when Amazon introduced S3 storage, it was kind of a big hit, instant hit in the market. And then everybody started realizing that businesses are no longer just looking at technology as a technology. They started looking at as if it is kind of a capex versus opex kind of decisions. And what that put in people's hand was a true power where innovations became faster. People started getting more processing power at their fingertips, and that put data into totally new dimension. Again, I'm reconfining everything to that discussion which we are having right now. How data streaming became suddenly the buzzword in the industry, right? It is not suddenly. If you look at these slides, it was continuously evolving. So imagine when data was first confined within the boundaries of their corporates, okay, data was still not traveling, data was still at rest. The moment cloud came in, okay, cloud penetrated into every departments, and data started getting, transferred between their local systems and cloud. But still, if you see in this slide, people to people interactions were still happening as it is. There was no autonomous systems talking to each other. Yesterday, you might have seen in Agentic AI session that how things have evolved, right? Consider or put that in perspective here. Would agentic AI been possible if the systems were living the way you see now? No. There was still a further possibility of evolution. So what happened is cloud started penetrating everywhere, and then technology also evolved, internet bandwidth evolved, and internet kind of connectivity became available to all. And that is where we entered the age of cloud 2.0. What happened is lot of technology offerings available in cloud started giving power to corporates where they started modernizing their business use cases. So when we look at cloud 2.0, you can suddenly think of those use cases. Compare these two slides, okay? I'm switching back to the previous slide where you see people are still interacting within departments to each other. Computer systems are present, and there is giving power to people, and of course power to the department, but nothing else. But then in cloud 2.0, you suddenly see customers appearing on the horizon, suppliers appearing on the horizon, and they are all connected. Business suddenly started behaving more integrated than ever before. So what that means is, imagine people who are, I would say, born in 80s or 90s. They witnessed a revolution in front of their eyes, where by the time late 2000s, okay, I'm saying 2005 onwards, all these people who were born around 80s time frame, they have seen two eras of business. Okay, let's take an example of banking. In banking earlier, as a child, I remember I used to go to bank, print those passbooks, and then whenever I go to that bank, people will actually tell me, give me your passbook. They will run through their computer systems. Earlier they used to run through the ledger. Okay, I have seen those days as well, where they will open the ledger, find out the account, and then in passbook they will actually give me a handwritten entry that this is your balance. And now slowly that become kind of a different use case, where I used to go to bank, they will just put the passbook in the printer, and they will just run a couple of commands in the machine, and then that machine will give me the latest ledger. So what that means is, you see here customers and suppliers appearing at the horizon. Basically, interactions with the corporate systems and data became possible with the evolution of cloud 2.0 and the technology, the way they evolved, right? Slowly, when I'm talking about late 2005, internet banking suddenly got introduced. I remember ICICI Bank in India was one of the banks who was leading in providing that digital interfaces to people, and it was such a convenience. Like, I was sitting in my office, and first time when I opened my ICICI bank account online, and it was such a pleasure. Hey, I don't need to go to bank anymore. I have to just go look at my account balances, print statements. I can do everything online while sitting in my office. So think, in that case, what was happening to data at rest? data started moving. Somebody goes and deposits something into ATM, and suddenly I start behaving as if, hey, somebody deposited something in my account. Now I want to see it sitting at my home and in front of my eyes. That wasn't possible before. So when data was at rest, okay, we were used to with this kind of use cases where we will go to bank and get our passbooks printed and then say, hey, okay, this is what my balance is. If somebody deposited something, I'll come to know probably after a day or 2 or 3, once that complete processing or that batch processing gets completed, right? But today, if we look at cloud 3.0, everything is hyper connected. Everything is hyper connected. So as we started getting towards technology, as we started getting along with the technology evolution, suddenly the data which was at rest, that started moving. And that is where the foundations of data streaming are laid. The data streaming suddenly became mainstream, and then everything is in motion. All right. And now this is where suddenly you see a lot of data is flowing in real time, and now those batch processing paradigms are falling apart. So what used to happen, let's say pre-data streaming era, okay, data is flowing all around, data is flowing between different systems. It opened, of course, many communication channels, creating a web of data exchange. So interdepartment data exchange was mature. It got standardized. If you see here, all the departments started talking to each other via computer systems rather than people. So people dependency was reduced for such kind of routine tasks, and people also moved up in the value chain. They started doing more business innovations rather than doing those basic report exchanges, right? So when such a creativity of people was focused in the business evolution, suddenly you will see businesses also innovating faster. Why? Now, no longer people are running with reports to each other. These are all exchanged in email. Also, the systems are sharing data, so people can probably look into each other's system and pull the data that they want. And that's how suddenly technology evolution put data into mainstream. That data which was comfortably sitting idle, or let's think of a data packet, okay, a poor guy who was sitting idle enjoying his life, data at rest. Actually, like when we think of a vacation ourselves, we go and we rest, right? But imagine you are in vacation mode and then suddenly, somebody makes you run. Hey, there is a fire, run out of this resort. And suddenly you start running. That's what happened to this poor data. Okay. Suddenly data started running all around. I mean, a customer is clicking on the web, and then that data is actually streamed into one of the systems where somebody wants to analyze it instantly and then give that customer a recommendation what he should be doing next or what can be upsold. Now, this is becoming a norm day to day. So, as systems to systems communication started becoming the normal, batch analytics and processings were unable to catch up with current business demands. And then that led us to one of the pre-streaming data flow era where line of businesses were literally struggling to catch up with the batch paradigm. Imagine this kind of an architecture where everything was kind of a mesh. Okay, there were applications talking to databases, there are applications talking to applications using APIs, there are microservices which are supporting these functionalities at the back end, data warehouses were actually collecting all the data, SaaS platforms were exchanging that data. And in this whole pre-streaming data flow, okay, people were still using that batch processing paradigm. So what used to happen is I ended up, surfing, let's say, Amazon.com or Amazon.in, for example, okay, and I browsed 10 different products. Amazon, when it runs its batch systems and does analytics, okay, it will come to know after a day or after probably, let's say, 6 hours when it runs its batch cycle. And then it understands as a customer, when I was browsing, let's say, bed sheets for my double bed, at the same time, I was also browsing furniture as well. Amazon could have provided me recommendations for buying chair, which are recently launched, but they miss this kind of opportunities when they do batch processing offline. So this is where there was a fundamental disconnect. Okay, reality was actually happening in real time, but data processing and moments was still happening in the batch. Okay, so by 2011, when cloud computing started becoming backbone of all businesses, okay, online presence kind of became necessity for all. User experience became prime differentiator for quality and business services. Okay, ability to support multiple business channels became the normal. So imagine Make My Trip, for example. Okay, you can visit makemytrip.com as a website as well, and then you can actually browse makemytrip.com on your mobile too. In mobile also, you may have a mobile application for Make My Trip, or you can have a mobile browser also acting differently compared to your desktop. So what this means is, suddenly when people in, let's take banking example. In case of banks also, people used to come physically in the bank door and then used to get the business done. But now people will enter through a mobile channel, people will enter through a bank physical channel, people will enter through a browser on the desktop, or people may end up, triggering some batch jobs, downloading statements for last 10 years, for example, and then suddenly system will enter a use case into the bank's technology landscape saying that, hey, this is another user interaction coming on your way. So this basically led to data points generation from different channels and syncing into business compute. What happens is that amount of data generated increased multi-fold. Okay. And then business started realizing the pain of historic batch processing approach. When everything is happening real time, how can you still rely on the batch processing and then be done with it? No, that's not the case anymore. And that is what introduces, why data streaming the motivation. We are again coming back to that same slide which we discussed earlier. Decisions now can't wait for the nightly batches. Continuous flow of data is there, logs are flowing, Internet of Things is sending lots of sensory data, users are clicking, and then click streams are flowing through your systems. And then users are also getting used to with this new paradigm of getting real-time experiences. For example, imagine you enter a shopping mall and then suddenly you want to have some good recommendations from the nearby shops, or there are nearby shops running a good deals, and you don't want to visit every shop to understand, okay, what is their sale offer today. Rather than you would expect them to give you that offer on your mobile, delivered right in form of a notification. Now this kind of real-time user experiences have started becoming norm. For example, take a Uber ride, take any cab booking that you do online. Okay, you are sitting in an area, or you are moving around an area, and then you are trying to book a ride with the nearby riders around. Is that possible using a batch system? Not at all. When user is continuously moving, his location data is continuously streamed into the systems, and that is where the need of data in motion arises. Okay, so when user is moving around, the nearby drivers are also moving around. So this continuous stream of data happening every moment has to be known to the system to make a right decision and allocate a right cab ride for you as a user. So traditionally, many systems lived comfortably with batch processing, but today's date, if you think now, this is completely disrupting the scenario. If a business does not change its batch processing habits, they are gone. Modern applications like fraud detection, ride hailing, real-time recommendations, sensor monitoring, etc., they simply just can't wait. They have to be done with the data streaming. Okay, and at the same time, organizations are also flooded with lots of continuous data like application logs, clickstream, sensory data, mobile applications, etc. So this is where there is a push for low latency decisions over continuous data, what is leading us to data streaming, shifting our focus from data at rest to data in motion. So now if we go back at this kind of slide again, you will be able to appreciate that when in 1970s, 90s, OLTP and RDMS were doing their job, people were happy. Data warehouses and ETL were processing that data, and big data batch analytics was mainstream. But when we started moving beyond 2010, the proliferation of technology everywhere started generating real-time data points, and that is where data streaming as a core paradigm was established. So having established this, okay, let's look into the beta data streaming. Okay, so batch was kind of a bounded data set, run job, get the result, higher latency, good for historical analysis. Okay, this is how we used to run. So when you run a job, it finishes, it gets your result. But in streaming, the input is conceptually unbounded. What it means is that there is a continuous flow of events happening. If a user is moving around a Uber ride, okay, Think of that, your mobile is actually showing you your correct location on the map. Even not even your mobile, okay? A person who is sitting in Uber's data center may also be able to see the same thing, that where currently the ride is, where currently the user is. You can see a classic use case when you book a Uber ride or a cab ride, okay? Until you both are coming together, your mobile application shows your location to you as well as your Uber location to you, or your cab location to you. So basically, this is low latency, always on processing paradigm that we are looking at, okay? And this is where we have to look how many modern systems are combining both batch and streaming paradigms together. So a few examples, okay, where we can correlate this shift to event-driven system, which has already begun long time back, right? Earlier, those who have seen this kind of telephones, right? We used to do an occasional call to a friend and be happy. I spoke to my grandfather, I spoke to my brother, I spoke to my friend, and then that was a life. We used to call each other and call it a day. No longer. Now you are continuously online, okay? Even while we are having this session, no wonder if somebody got distracted into Facebook or Insta. I mean, that's a part of life, right? I mean, I'm no offense to anyone, but just to understand, like, this is how people are dealing with the information today. I'm sitting in a session, and it is quite possible that somebody calls me up and says, "Hey, did you check somebody else's Facebook? There's something going on." And suddenly, for a moment, I'm distracted. Not intentional, maybe yes, but this is the reality. Everything is happening in parallel. You suddenly and sitting in this session, and somebody gets a notification, "Hey, there is a withdrawal from your bank account." Suddenly, you get anxious and tap on that. You are again at two places. There is a data streaming currently from my desktop to yours. At the same time, bank is also streaming data to you. Something happened in your account and instantaneously notifying you. So there is a continuous stream of events all around us at this moment. Okay. Earlier, we used to read a daily newspaper come to us in the morning. We used to eagerly wait for that. At least I recall those days. And today, everything is at the fingertip. The moment I want, I just want to go to Twitter or Insta or anywhere, and I start checking the news and stories and all. Sometimes I subscribe to the news feeds as well, and that's accessible on time, anytime, everywhere. And this is where you can understand truly that we are living in an era where data is in motion. So what this impacted is that there are few businesses which were born cloud native. Example, social networks, they were like completely born with the cloud era, and then everything was done in such a way that you will see them as early adopters of data in motion. And those were traditional systems that adopted over the period of time. So those print newspapers becoming slowly online, and then slowly becoming real-time newspapers. Okay, you look at Times of India, you look at Indian Express, all these news channels adopted this over the period of time. But whereas social networks like Facebook or Insta, they were born cloud native. They adopted this thing early. So streaming provider, on-demand digital content providers like Netflix and YouTube, etc. They all started, kind of that cloud native data in motion approach. Whereas credit card payments, okay, slowly evolved from, that legendary banking style processing into credit card payments, microservice architectures and all. Similarly, Uber, ride hailing, basically booking online cabs and all, they slowly became, they were born cloud native, but the traditional cars, they are slowly becoming, connected cars as we move ahead. So what this is leading us to at the end of the day, when we look at data in motion, definitely the way we exchange data is not going to help us. If I go back, few slides here back, okay, and I give you that reference again, think of this architecture. In this architecture, when we were transitioning and evolving over the period of time, okay, everybody was talking to everyone. There was a point-to-point communication happening. And now in such a scenario, imagine if you want to implement a service like Uber, where you want to real-time track everything. And one application is supposed to talk to 5 different people at the same time. Is that possible in like practicality? No. There are multiple hurdles to it, multiple possible failures to it. Being a computer science student or being a computer science professional now, we all understand that when you call an API, it can give you 200 okay when your luck is shining bright, but it can also throw you 400x or 4xx or 5xx errors. What happens at that time? this point-to-point communication fails very badly in such scenarios. Again, keep that in mind. Data is in motion. Everything is supposed to be looked into it as an event. For example, I booked a cab. It's an event. And that event is not supposed to be lost. It is supposed to be captured somewhere. So what I'm trying to make us all understand here is this is leading us to a requirement where we need a single platform where we connect everyone to every event. Basically, suppose if I book a ride, okay, on Uber, or let's say online food delivery, we all are fancy with that, right? The moment I book a online order for a food, okay, I have booked, I'm done, and then I don't care after that what happens behind the screens, but I am guaranteed within 10 minutes or within 20 minutes or 30 minutes, my food is going to get delivered. This is a very dominant use case in metros. I'm not sure about if this kind of a use case is penetrated to tier 2, tier 3 cities in India. I hope so by that by this time now. But basically, I hope you are all able to correlate with these examples, right? There is a real-time stream of events which is happening, and our current communication technologies or the current technologies which support interactions between people to system or system to system require some sort of modernizations. And also these events which are happening, these are not supposed to be lost. So once that event has happened, somebody should be able to look into this event in past as well. Okay, and this is what is introducing us to the data streaming paradigm. Okay, where data is in motion, but at the same time people should be able to capture it, people should be able to use it, and people should be able to reflect upon it at some point in time. Okay, so once we understand that, how technology has evolved, how data is moved around, and then there is a need of a kind of a platform which helps us. Okay, let us dive further into the subject where we say everything is being modeled as event and streams at the end of the day. Let that sink in. Okay, what happens is earlier it was a transaction where, let's say, I click on generating a statement, okay, inside my bank screen on internet login, and then that used to trigger a call to the backend database in that three tier architecture, and then that database will actually pull that transaction statement range, and then my middle tier will actually assemble everything, curate everything, and then it will be presented to my tier 1 where user interface will show that statement, everything happening synchronously one after another, everything is happening in coordination. But events are asynchronous. I'm taking a pause. Let that thing sink in our mind. Events are asynchronous. A request generated, think of that a request generated for a bank statement actually becomes an event and lands into event stream. And that's it, done. The producer of the event doesn't care or need not care by design. I generated a statement request, it got queued. And then when that request got queued, what happens is it's up to the underlying technology to make sure that event got registered, event is available for consumption, and event is available for historic analysis if at all required. So what happens is, in case of data streaming, okay, platforms which support this data streaming actually forces us to think a little differently. Earlier, we used to do assembly programming, and I'm sure faculties over here might have remembered those days. So when you were doing assembly programming at that time, those opcodes used to be our mindset. Okay, we used to think of everything in terms of opcodes, and that is where the paradigm shift comes. Okay, so when somebody talks about a loop, okay, immediately something was struck to our mind is that jump if not zero or jump if zero, opcode hex 32, opcode hex 34, and then we used to start thinking and coding like that. Then slowly, let's talk in perspective of C programming. Suddenly our vocabulary changed. We no longer used to think in terms of opcodes, but we started speaking a little higher language. How? We used to say, hey, write a loop, okay? Just do 10 iterations and then process this data. Hey, why don't you do branching here, do if else, and then, write a switch case. Now think about this. When I say write a switch case, actually, indirectly, I'm talking so many machine language instructions, but my layer of abstraction has changed. I'm talking a high level language now. Now let's move from C to C++. In that case, we suddenly started visualizing world around us as objects and classes. And we started modeling, this in terms of classes. So if you think of a banking system, then passbook may become a class, and then, get balance becomes a method inside a class. And now I'm suddenly talking another level of vocabulary, one more level higher. So the way we started modeling everything as class and objects in object-oriented paradigm, okay, this is event and streaming paradigm. What we need to do here is that start thinking or modeling the world around us as events. So user clicked on a screen, event. A user is trying to book a ride, event. A user is trying to, shop something, event. User added something to cart, event. User did a checkout, event. User cancelled the order, another event. Everything is events at the end of the day. And when these events are flowing, definitely we want to also receive these events in the given order. And that's where the streaming platforms make sure that older events and newer events doesn't get mixed up. Events are coming in as and when they get registered. Okay. Now, when we talk about this, think of a pipe, okay, which is actually going to be your backbone or a platform which is going to take care of your events, okay, where events are entering into the pipe from one end and then from the other end that gets consumed. But unlike those traditional pipes, okay, data streaming platforms are actually enabling multi-producer, multi-consumer scenarios within those pipe semantics, okay. So given a event stream, okay, multiple people can actually produce, or multiple producers can actually produce into that event stream different events. And then that can be consumed by an application or can be consumed by an event sync, which could actually deliver that event to a database, for example, right? And now slowly this kind of paradigm shift started happening. So if I take you a little more zoom in kind of a scenario over here, take a look at this slide, okay? Streaming platforms suddenly started offering this kind of semantics, and it forced people to think differently. So there is a right semantics optimized for that. The streaming platform is basically optimized for the right semantics. Then producers and consumers are decoupled in space and time. So earlier, imagine, okay, read semantics were like that, where a microservice is calling a database, and then that database, if it is offline, that microservice fails, okay? Or if that database is currently busy, that microservice experiences latency. And then the API calls, which are made from system to system, microservice to microservice, or from microservice to database, etc., they were tightly coupled. So if database is offline, suddenly your whole workflow will fail, right? Whereas workflow started getting modified, okay, the producers and the consumers were decoupled. So when I need something as a, consider the example of a bank statement, or let's talk about a very simple use case of ride sharing or ride booking. I'm trying to book a cab, and I don't want to understand how many drivers are there in my area right now. I just say I need a ride. I am at GPS, or I am at GPS coordinates X and Y. These are my lat longs. Give me possible rides who are around me. That event, when it lands into one of the event store or data topics, as you see here, okay, in real time, there are multiple consumers where one orders, one starts looking around, after consuming that event, one suddenly starts looking around cabs which are moving in your area. One consumer consumes that and then start recording that into transaction logs, saying that, hey, this user requested a ride. And then one user suddenly starts calculating the route, possible options, and the prices that can be offered. This three thing can happen in three different applications which are consuming that same event. Imagine if you have to implement this with an API, what a complication you would face. it would be, the systems will be highly complex. So if you focus on the right side of the diagram, you can see that basically that platform which you see as an event streaming platform, okay, that has started enabling producers and consumers to become decoupled. So users started becoming decoupled from the system, and that's how, high availability suddenly become a norm where user will never experience a failure. He will eventually get his result, but that's how the workflows started getting modeled. So the moment I book the ride, sometimes Uber may take 30 seconds, sometimes it may take 300 seconds, but at the end of the day, your ride booking is done. So write, read, process, streaming app is basically able to process that data and then do some enrichment on top of that as well. Now these are additional use cases started emerging. We will get into that, okay? But basically, if you look at this architecture and focus on the right side, then various use cases started appearing on the streaming platform, which suddenly became mainstream. Okay, somebody wants to move data to cloud. Okay, then of course that is possible. Somebody wants to change data capture stream from a database. Of course, that can be relayed as a stream of events, and then system can actually act on it. Then message queuing, like two applications sending data to each other, like IoT sensors relaying data to their hub. They can start queuing their messages. Logging, like anything happens at the end of the day, logging becomes kind of a system of record to understand the behavioral pattern. That can also be streamed. And we know a lot the way Twitter, Insta, Facebook, and all behaves in real time, right? So basically, we are looking at a streaming platform which is enabling all these possibilities. So this is how a streaming platform would look like at the end of the day when you embrace that as the core of your business to handle data in motion. Think about it. Earlier, we saw a complete mash of communication pattern happening, and you would see, if I go back few slides here, you would be able to correlate. Like earlier, businesses used to view their technology landscape like this: applications talking to SaaS, application talking to applications, application talking to databases, and then data warehouses present everything over there. And now with the streaming evolution, okay, suddenly this become a possibility. So imagine a platform like Apache Kafka, which we are going to cover up in a short while. This kind of a platform suddenly became the center stage of any organizations, okay, where this whole spaghetti, which we saw just now, everything is talking to everything, started becoming simplified, and everybody started modeling the way we talked about C++ analogy, right? The way things were modeled like objects. Similarly, everything is now getting into that mindset or that modeling lens where everything is viewed as events. So IoT sensors can keep generating events. For example, there is a temperature monitor inside a refrigerator which is on a moving truck, right? It can monitor the coordinates, it can monitor the fluctuations in the temperature to make sure the groceries which is being transported, or let's say a fish, meat, or anything which is being transported, should not face any temperature violations which can degrade the food quality. Now, these are the kind of use cases becoming possible today. When that system suddenly sees a fluctuation, it can actually, that continuous stream of sensor events can be monitored as an event, and then that processing can be done on top of that to understand, okay, temperature violations are happening, temperature is dropping below a threshold, and before it breaches a final threshold, okay, that watermark triggers an alert to the driver to stop the truck and monitor what is wrong with the refrigerator in his truck. And that can save a lot of money for business because of the temperature fluctuation. They might have to throw out that whole goods being transported under specific temperature conditions. Think about medications which require certain temperatures to transport. These are all possibilities now. So similarly, mobile device, SaaS application, edge computing, data centers, microservices, you name it, everybody is at the end of the day started leveraging events. So what a streaming platform offers in such a scenario is that it kind of becomes a central nervous system for your organization. It gives you a global scaling capabilities. It gives you data in real time. So when streaming systems comes into the picture, imagine a sensor send a data, but then if you are not able to consume within microseconds latency, how are you going to keep a check on this in real time? So streaming platform emerged as a backbone of the organization, which started giving you low latency real timeness in terms of processing those data. And of course, those events need not be just transient into the system, they can persist as well. So, streaming platform started emerging with those capabilities as well, where I dropped an event, it remains there for 1 month or 1 year, depending on my wish. Of course, it comes with a cost, but at the end of the day, this is how it is supposed to be. And then stream processing became a new paradigm in that case. Okay. So far, okay, I'm just giving a quick recap that we understood how data started evolving with the evolution of technology and how it forced everybody to change. And with the evolving technology landscape, okay, how we have landed into a streaming era and how that gave a birth to the necessity of a streaming platform. Okay. So streaming platform should give us high throughput and low latency, during durability and fault tolerance. It should be highly available at any point in time. I'm relaying my critical events of the business, right? I cannot have it offline anytime. Scalability, decoupling of systems, right? All this became a norm. So let's recall this slide which we looked earlier. Okay. In cloud 3.0, when we landed, okay, we saw this complete spaghetti where everybody's talking to everyone. Businesses are looking at technology as one of the complex department, okay, to handle. And everything is like kind of becoming so complex that introducing a new use case or doing a business innovation requires a lot of amount of preparations and analysis to understand what all gets impacted. For example, imagine if sales department is changing something in their database. Okay, now consider this whole spaghetti of interconnections. It may impact marketing workflows as well, it may impact product department as well, it may impact operations as well. Imagine a single change in a database structure. Okay, I ended up modifying a column, and let's say I ended up changing a data type, and boom, everybody in the company gets impacted. Hey, why did you change the data type? Our flows are breaking, our code is breaking, right? So it's basically very complex point to point communication, single point of failures, data inconsistencies, no standard format was giving pain to organization to evolve further. And now if you look at this, the moment streaming platforms started becoming central nervous system of an organization, suddenly there is a clean breeze of air. Every department can become independent. Every department can handle their data in their own way. But they all agree upon a contract where when they publish the event, that event will have XYZ field. Think about it. The previous slide shows the total mesh architecture where point-to-point communications are there, many-to-many interactions are there, and everybody is exposed to everyone. A single change in the core of their system can impact who else they even don't know. And now, with the era of data streaming, suddenly everybody started modeling their use cases around streaming paradigm. Everything becomes events, and when these events are published to data streaming platform, they become a standard way of exchanging data. And this gives a birth to a new case of use cases which suddenly became possible and became easy to implement, and corporates started to innovate on top of that. So real-time fraud detection became possible. Okay, people were actually able to monitor continuous flow of streaming events coming from a credit card spend, and then people can act in real time, detect the fraud, minimize the risk, and improve customer experience. Think about that. My credit card spends are coming continuously from India location. Okay, and then there is a consumer which is monitoring that. and suddenly there comes a swipe from London, and then system can easily detect that this credit card was being used in India just a minute back. How can it suddenly appear in London? It is a fraud, it is a threat, and then that transaction can be blocked in real time. These are the capabilities that streaming platform gives you. Think of automotive, right? Currently, the future of the complete automotive industry is in the real time data. So major automotive companies such as Audi, BMW, Porsche, Tesla, they started actually using streaming platforms like Apache Kafka. So allow me to introduce this word here, okay? Apache Kafka, it was actually developed in LinkedIn as one of their internal projects, early 2000s. And then by 2010, okay, they actually made it mainstream, and they made this Kafka become Apache Kafka by making it open source. They incubated that and they made it open source, and that was actually a kind of, I would say, a big paradigm shift which became possible with the introduction of Apache Kafka in the streaming technologies, right? There are multiple technologies available. However, Apache Kafka is one of the leading streaming platform, and of course kind of a de facto standard being used worldwide. So currently what we see is major automotive companies are using Apache Kafka typically as a central backbone in their cloud-based data platforms. And you would be like, surprised to understand that these all automotive companies are running massive Kafka infrastructure to process trillions of data points per day, coming from its vehicles or energy systems or factories, etc. Okay. And this data is used in real-time decision making, predictive maintenance, and enhancing autonomous driving features. So imagine your vehicle, okay, you have a car and you are driving this every day. Your vehicle is generating, that report whenever your car is running, how all systems perform. Now, let's say your engine temperature remains continuously stable at a point, but the moment that engine temperature starts fluctuating at some point in time, your data gets relayed to the company system, okay, as a streaming events, and company can actually notify you that your engine heating or cooling system is about to fail. Earlier, we will not come to know this kind of things until we actually face a failure in the middle of the road, and then we run around to find a mechanic. But now your engine is about to fail, and imagine five mechanics ends up calling you, hey, I'm giving you service at 5% discount, 10% discount, come and see me. This kind of use cases are being worked upon. Okay, hyper personalization is happening based on your driving habits. Okay, and then infrared cameras are sending data, and your sensor cameras, your sensor data is being monitored, your crash sensors data is being monitored, traffic alerts can come to your vehicle in real time. These are all possibilities now with the streaming platforms. Okay, similarly, governments is also leveraging. Imagine the big bureaucracy like government, if they become enabled on this streaming platform, what can they achieve? There's a lot. Real-time e-commerce also have become a norm. So what is basically, enabling that? Okay, or let's look around these streaming use cases for a moment. With the era of streaming, okay, we can do messaging, we can do website activity tracking, we can do metrics manipulations, basically read metrics, process them. We can look at logs aggregation, we can look at stream processing, event sourcing, commit log. Think of these use cases and then think what else can come to your mind. So basically, streaming has opened up all these possibilities. And then let's dive further deeper into this one, okay? How streaming platform works, or what enables data streaming at the end of the day. We saw this diagram, right? Where a streaming platform like Apache Kafka becomes a central nervous system, and then your complete spaghetti or that mesh communication gets simplified like this. And definitely organizations love it. The CEOs, the business people love it because that enables them to create new business innovations very easily without disrupting their organization. Of course, it saves on cost and it enables them to innovate faster. So how does that look like? Basically, streaming platform at the core is nothing but a distributed commit log. Now, I'm making certain assumptions because we all are having a mature audience over here. So this distributed commit log is basically having a kind of, a multiple brokers based system where you imagine a Kafka cluster at the center. You see in the diagram at the top over here. That cluster is basically made up of multiple brokers. Okay, these are highly available and fault tolerant. Redundancy is built in, and then availability is designed in such a way where if one broker goes down, still remaining brokers can serve the traffic of producers and consumers and be highly available by the time you bring the broker back. So kind of, continuous becoming available is becoming a de facto standard now with Kafka systems that I have been exposed to. So I started working on Kafka systems probably 5 years back, and I did went through a series of certifications to understand these systems in a deeper level. So I completed a couple of years back certified developer for Apache Kafka. I also did my data streaming engineering certification, and now I just completed certified operator for Confluent Cloud, which is one of the leading provider of Kafka cluster. And understanding, looking at this inside of these systems truly amazed me. Imagine a Kafka cluster is running, let's say, 5 brokers, and these 5 brokers are giving redundancy to each other. Not only that, they are geographically also spread apart in different regions inside the cloud. So let's say one region is in US East Coast, another region is in US West Coast, and then let's say third backup region is operating somewhere in Europe. So any geographical event causing disruption to one of my brokers or one of my network link in my data center will still not uh, impact me in a way that my Kafka cluster is continuously available, and all I need to make sure is that I design redundancies in the architecture so that my producers and consumers are able to reach other brokers and produce and read from them. At the center of this Kafka cluster or any streaming platform, okay, there is something called as topic. Okay, so what is this topic? So this topic is made up of multiple partitions, whereas the moment you start producing writes, you can see on the right side in the bottom here, those writes gets landed into these partitions, and then depending on the keys used in the events, okay, these events actually land into these partitions, and then they are guaranteed to be in order with respect to their partitions. Now, imagine in this way that when a producer is continuously producing events, those events get distributed to these multiple partitions. So actually, kind of load balancing algorithms are built inside this kind of libraries which interact with the platform to make sure your events are equally distributed across these partitions. Now, on a topic, you can have multiple consumers read at their own pace from these partitions and start consuming these events one by one. And then in this topic, the data can be retained for hours, for days, or for weeks. Okay. So a topic is split into partitions. Each partition is also replicated for fault tolerance. Okay. In this kind of streaming platforms, producers keep appending events to the partitions often. Okay. Partition by the partition key. For example, imagine a customer ID becomes a key so that all events pertaining to a specific customer are guaranteed to land in a specific partition in order to ensure that ordering is guaranteed over here, right? Consumers keep reading from these logs independently, maintaining at their own offsets, right? They keep reading this, and imagine how this architecture brings in beautifully the decoupling of producers and consumers in time and scale. You can have multiple producers producing at their own time, and you can have multiple consumers consuming at their own time. No dependencies as such, right? They both can continue operating at their own pace and then continue going from there. Now, this is the beauty of the streaming architecture, right? When you have a decoupling, definitely a lot of design patterns can actually start triggering in your mind. We will avoid discussing that for now, but let us understand that, when you establish Kafka kind of a platform as a central nervous system, okay, so then what are supposed to be or what are supposed to be the norms that we should be aware of? So again, this is another example of how an organization could look like using your streaming platform as a central backbone. So all the important events, they flow into the same Kafka platform into various Kafka topics, right? So applications, databases via change data capture, IoT devices, logs, they all publish their events into Kafka. and then downstream multiple consumers subscribe to this kind of topics of their interest. So it could be analytics system, it could be microservices, it could be monitoring tools, machine learning pipelines, search indexes, and more. And the key idea basically over here, or when you actually think about teaching this to students as well, it's the loose coupling between the producer and the consumer. Producer just write to Kafka. They don't worry who will consume the events. They even don't know. New consumers can be added later without even changing producers. Okay. So this architectural pattern which you see, it is basically mirroring the operating system and hardware buses, as we all know, right? But now this is happening at a data center and at the scale of the cloud. Earlier, we used to see this kind of architecture happening in the operating system's internals, but now this become generalized and available to all in data center and cloud. Okay, so think of this. Okay, events, topic, and streams together. Okay, this is I'm using a Kafka terminology a bit. This terminology can vary from platform to platform in case of streaming. However, the nuances remains the same. Okay. So when event, if we look at event, okay, how to look at event or what is an event? At the end of the day, event is a immutable record of something that happened. Period. A purchase, a sensor reading, a click, this all can be classified as an event, and these events are immutable. A sensor reads a temperature and records that 31 degrees Celsius is my current temperature. It gets published into the Kafka topic, or for example, your event platform, your streaming platform topic. It is an immutable record. Whoever wants to read, they can read it, but they cannot modify this. Okay. Topics may have some naming or streams of similar events, right? Where each topic is split into partitions, but at the end of the day, topic group similar events. So, for example, consider a topic called payment. So, then that topic contains everything that relates to payments, events relating to the payments. And then each topic internally will be split into partitions in an ordered append only log, kind of. This is how Kafka scales and preserves order within a partition. So we saw in the previous slide, right? Within a topic, you see multiple partitions, and based on the keys, your events are guaranteed to be ordered within those partitions so that your consumer receives events in the order they arrived. So ordering is guaranteed as long as your keys are uniform. We can actually deep dive into those algorithms around how those key distribution takes place and how that event distribution takes place across partitions, but not now. I will leave this for further research. Okay, but at this point in time, okay, the partitions is definitely having those events recorded, and offset is a position of an event in a partition. So again, I go back to this slide. Okay, your event lands at offset number X, Y, Z, and so on, and your consumer keeps track of reading these offsets one by one as and when they progress, right? And then there is a stream. So basically, stream is nothing but a topic or a set of topics viewed over a time. So imagine this diagram again, okay, where your continuous production of events are happening depending on the data being sent by your sensor or logging system or your click stream coming from your browser, and then those are converted into immutable events and then landed in this topic, and then there is a consumer which reads this continuously and keeps processing them. I'm abstracting things out just to make sure that things are simple. We understand data streaming as a concept and grasp that as a subject. And further details, if you have any questions, feel free to reach out to me later. I can help you out. But couple of important things to remember around event is there are two important things that we need to understand. Okay, in event there are a time and delivery semantics which is very crucial for data streaming platform. So in event, okay, there could be two time. One is that actual time when event happened, and there is another time when which is known as a processing time when it got processed. Okay, and for example, a sensor generates an event at time, let's say 1 o'clock in afternoon. So then that is an event time. But then it may take a couple of moments before that events get processed and actually get delivered into the streaming platform, which can be known as processing time. Okay. So handling late events or out of order event is a first class concern in the streaming era. So when you are writing a consumer for a streaming platform, okay, you would be interested in knowing the time of event and the processing time. And that is where we will understand that when our system handled the event versus when our system actually recorded the event. So I will introduce one more term called, stream processors. There is a technology called Flink, which is complementing Apache Kafka these days. We'll get introduced in the next slides, but then that is going to actually tell you how stream processors are actually using this event time semantics to keep track of events. Okay, and then there is delivery semantics, which are definitely given by different kind of producers and consumers to make sure that your event doesn't get lost, and at the same time your events are recorded on the platform. So there is a delivery semantic called Atmos once, where an event may be dropped but never processed twice. So this is a consumer semantics. Okay, then there is a at least one semantics, where an event is processed once for sure, but it may get processed more times because duplicates are possible. So I will quickly touch upon this aspect. At the end of the day, that platform is a piece of software which is running somewhere inside cloud, which is dependent on your multiple factors like your network, your bandwidth, the compute power available to the clients as well as to the server, right? And in these all things, let's say a sensor is trying to send the data to the system, right? And the network link gets broken. So that data got actually committed into the streaming platform, but acknowledgement did not come back. And sensor thinks that my data did not reach my platform, and it ends up sending again. Now, in that case, what happens is duplicate events are possible. I am avoiding deep diving into this because this is further subject of research from the academics perspective as well, right? And this would be very interesting for definitely few of the faculties working closely with this kind of concepts. So at most once, at least once, and exactly once. In practical sense, end-to-end sense, exactly once is the effect as if each event was processed exactly once. Okay. So these data streaming platforms revolve around these two important concepts of time-based semantics and delivery-based semantics. Okay. Moving on to the next one. Streaming on campus, kind of an example that I tried to capture, considering that you all are dealing with our academic institution. So this is just an example I am trying to model here, that if we think of implementing a streaming on campus use case, then what would it look like? So events could be like, when student enters a gate, it becomes an event. Student swipes the badge and then enters the college campus. It suddenly becomes an event. When student exits the gate, again it swipes the badge. Okay, student swipes the badge and then it generates an event. So then these are kind of real-time events, that student entering or student exiting the gates. Similarly, when a class is started and class is ended, imagine there is a mechanism to record that events as well. So then these are the kind of events, the simple possible use cases, okay, which can get implemented as a streaming use cases on campus. And then what kind of topics could be modeled around this is basically turnstile events, where student movements can get recorded. Okay, and then class events, where you understand what are the different types of classes currently going on campus, how many parallel classes going on, okay, who is teaching where. These all kind of things are possible. Imagine that we are modeling everything inside those topics as an event. And the consumer does what? There is a real-time security dashboard. Imagine a security person sitting in college campus monitors a real-time how many students are currently on campus. Okay, if a professor is looking for a specific student, he can also actually query this dashboard and understand if the student has come to college today or not. Right? You can straight away run attendance analytics and reports on top of that, like today how many students are currently on campus, or yesterday how many students were there, how many students were on an average present in the classes in last 1 month. Okay, or what was the average attendance in the class. And imagine this data is being consumed by a ML model. So I'm sure yesterday in Agentic AI you must have talked a lot about how we can enable AI and then run it in agentic mode. So imagine this data becoming available to machine learning models, and then it starts finding anomalies and unusual patterns around that. and then that's it. I mean, this is what you have arrived at the new age, actually, right? So this is just for reference, like, it's kind of a food for thought for all of us to think, what can we do with streaming platform, given that we have run through this amount of slides, 1.5 hour of talking on streaming, right? But I will quickly cover a few more things around streaming, and I think we are coming to an end to our session now. So what are the different stream processing engines currently that we see, from batch to streaming, kind of a migration that we see, right? So basically, Kafka kind of platform gives us logs of events, but we still need engines to process these streams. So sometimes you can write your own code which can actually consume these events, and then you can write a customized processing on top of that. But now in technological landscape, okay, streaming engines have started evolving, which consumes these topics as an event and then performs this all analytics or kind of further anomaly detection, etc. on top of that. So Hadoop MapReduce was earlier batch only, and it was great for big data, but then it was slow, right? Spark started introducing streaming refineries where it converted this big batches into micro batches and small time buckets processed repeatedly. It started supporting that kind of use cases over the period of time. But Storm and Samza were among the first to do event at a time streaming. Okay, so these are the kind of engines which you can actually plug to this kind of streaming platform and then start consuming events. So stateful streaming got become a reality with Apache Flink coming into mainstream. I will introduce in the next slide how does it look like. Okay, and Apache Flink basically advanced this whole stream processing further by offering stateful stream processing. Okay, with stronger guarantees and sophisticated time handling. So think of time window based aggregations, joins, then filter, all this kind of rich use cases you can perform on streams, and then think about this. Okay, so I'll give you one example. In the previous modeling of this university students, okay, having their data coming into class events, okay, imagine you want to run an analytics that which class has less than 50% attendance in last 1 month. Okay, so then this stream processing engine can actually get plugged into your topic. You write your queries or you write your no code, low code kind of solutions into the stream processing engines, and then this engine will run through the amount of events available in your topic. It processes that and gives you the result that, okay, in last 1 month, based on your query, this classes had less than 50% attendance. So modern Flink versions, like, moved toward a unified model where batch is just a special case of streaming and operating on bounded streams. So stream essentially in nature is unbounded, but then when you bound it, actually it becomes a batch, and that's how modern streaming engines, okay, like Flink 2.x onwards, they started doing unified batch plus stream processing. So how does it look like? I mean, this is again based on that simplified spaghetti architecture where introducing a streaming platform in the center suddenly beautified your corporate architecture. And now imagine a platform like Kafka is actually becoming a backbone of your organization to stream events. And then Flink kind of compute engines which are sitting on top of Kafka, and they are closely coupled with Kafka to read those streaming data and give you the results that you want. So how does a typical, a Flink use case looks like is that while Kafka focuses on transport, storage, and distribution of events, Flink is about the computation over those events. So Flink jobs keep state, okay? For example, counts per key, running, aggregates, and sessions, right? It has event time semantics we spoke about, watermarks to reason correctly about lateness and out of order events. It offers rich windowing, tumbling windows, sliding windows, session windows, etc. to compute on these streams, right? I want to see, okay, every 1 hour, how many students are entering in my campus, in my college, right? So then Flink kind of engines now currently making it very easy where you can write a sliding window query, and then at any given 1 hour, or they can actually give you a windowing query where every interval of 1 hour, you can compute how many students entered and exited the gate. Now imagine the power of analytics being unleashed with this kind of processing capabilities. What else can be done, right? At one point in time, if we want to introduce a certain scenarios which models around the availability of students in campus, this kind of processing becomes a backbone of such use cases. Flink also uses checkpoints. Flink also uses Flink SQL data stream APIs to consume from here, right? So our intention is to not to dive deep into the Flink capabilities, but just to understand the overall landscape of how stream processing is happening and how these systems are combined. So if you look at this slide, okay, this slide shows a typical canonical architecture, how you can, understand the Flink, and probably, even in future, we can use this to share with students as well. So producers or data sources continuously producing to central streaming platform like Kafka, where events are organized under topics and within that under partitions, right? Flink reads from these topics and ends up producing to another set of topics in Kafka, right? So imagine Kafka has one set of input topics, one set of output topics, and between them, okay, Flink is sitting as a processing engine which actually enriches event or filters event or does a lot more than that. So for example, a sensor in a refrigerator on a moving truck might be sending sensor data every 10 seconds or every 1 second, okay, or let's say every 100 milliseconds. Now in such kind of scenario, you are receiving tons of data, but then your consumer is only interested in the violations. It doesn't want to process 1,000 events to understand 10 violations that has happened throughout the day. So Flink kind of engines, they do this stream processing, and what they do is they run filter use cases where they say, okay, temperature, any temperature above 24 degrees centigrade, move it to another topic and make it available to consumer. And then what consumer does is consumer comes and says, hey, I want to process sensor violations. Let me know which topic I should consume from. So then the organization runs a governance and says, hey, this is the topic where you will get all the sensor violations. Just start processing them. And that's how we are simplifying the processing load on the end consumers and shifting left and moving all this kind of computations into the central backbone. This is what is currently streaming is doing in the industry, right? A Flink job reads from those topics and applies business logic, parsing, filtering, enriching with lookup tables, etc., and then computes windowed aggregates, joining multiple streams, and then writes results back to Kafka topics, which can be then further synced to external databases. So this whole streaming technology now started coming with a plug and play connectors where ready-made components of the shells are available. I just say, hey, configure one connector which reads from a topic and delivers my results to Amazon S3. Now think about this. I can write a connector which captures change data capture from MongoDB, puts that data into my Apache Kafka. Flink does processing, puts that data into output topic, and from there is a connector which reads that and delivers it into Amazon S3, where it can be further sent to data lakes, data warehouses, or data lake houses. I'm sure, to my understanding, this is touching all the subjects of computer science that you all collectively are dealing with today. Flink and Kafka kind of combinations are becoming de facto standard for stream processing across organizations. So if you look at data streaming landscape at very high level in 2025, I mean, you will be amazed. Kafka is the most common as a backbone, okay? But you will also see Red Panda, Pulsar, managed offerings like MSK, Event Hubs, PubSub, offered by various cloud providers. You will see various stream processing engines as well, okay? So Flink is there, Spark structured streaming is there, Kafka streams is there, SQL on streams engines like KSQL DB, etc. is also there in Kafka. Then there are managed services like cloud providers and vendors now offer fully managed Kafka and Flink in cloud to reduce operational complexity. I have done it myself and I know what all it takes to run a Kafka cluster locally. You need to deep dive into the subject. You need to understand the nuances around whole streaming capabilities. I mean, today, whatever we discussed, trust me, it is just hardly 10% of the depth or maybe even 5% of the depth that we are dealing with on day-to-day lives while operating Kafka in organization. So when you are actually trying to run and operationalize Kafka by your own, it definitely increases a lot of complexity. And now cloud vendors have started offering managed services. All you need to do is just click into your cloud and pay the bill. Again, it is capex versus opex. Okay, as an educational institute, what you can do is think about it. I can give hints, but I don't want to right now just pollute the minds with my suggestions. So I will keep it open for discussion for you all. But then integrations, right? Connectors, landscape is coming up where streaming platforms are connecting to input and output systems. And most importantly, data lakes and machine learning platforms. Okay, so imagine a stream of events available as a topic in your streaming platform where there is a connector which reads this stream and feeds continuously to your machine learning platform, and enabling your agentic AI to leverage this continuous event of streams to learn and detect anomalies in real time. This is just one of the use case. So what we want to see, or what we want to understand at the end of the day over here, is that we saw the whole history of how technology evolved, how corporates evolved, how data processing evolved. And as of today, if we look at this landscape, streaming is now a mature ecosystem. It is not just a niche anymore. Okay, and that is where we all need to understand how we can take this back to students and make them understand. Current trends in data streaming are like streaming as the default for new analytics, right? Companies are increasingly powering their dashboards and KPIs from streams directly, not just from nightly batch loads. Streaming plus Lakehouse is becoming another unified batch and stream architecture approach, where data is continuously going to your Lakehouse, and from there, analytical and ML training is also happening continuously. People are started now with running SQL on streams. Actually, people can query streams using SQL and reducing their barrier to entry, right? You don't need to write a specific code to consume a stream. Flink kind of tool started providing you a very low code solution where you can say select star from sensor topic where temperature less than 24. That's it. Internally, it runs the code and gives you a data at your disposal. It is as simple as that. Event driven microservices, instead of using this continuous request response model, API to API communications, now microservices publish and subscribe to this kind of event streaming platforms. And last but not the least, the real time machine learning features and online inference, right? Streaming is crucial in this cases where real time feature generation and online inference are required from the machine learning models. For example, you have some browsing habits in Amazon.com or .in, and then runtime recommendations are coming from Amazon. Hey, you can buy this, you can buy that as well. Similarly, payment processing systems are giving you fraud scores on the fly as and when this is happening, right? So what are the summary and key takeaways, okay, from here onwards? Okay, we all need to think. Given that landscape of streaming, we understood how it works, we understood the ecosystem, we understood, okay, how it all integrates with the courses that you all are teaching right now. In database management system, you can extend topics on logs and replications by showing how a commit log can become a streaming backbone. Introduce concept like change data capture and event sourcing. In case of someone teaching distributed systems, you can use Kafka's replication and partitioning. The Flink's checkpointing as used case studies and consensus and fault tolerance of Kafka platform itself. Somebody teaching big data or data engineering courses, okay, you can add a mini module on Kafka and Flink pipelines and understand how they complement batch systems. Somebody who is focused on algorithms and theory, right? You can also connect to streaming algorithms that must operate within a limited memory on unbounded data, approximate counts, caches, windowed aggregates, etc. Right? And for practical student projects, okay, consider a campus focus scenarios like the one example that we talked, that we just discussed. Okay, real-time bus tracking can be implemented. Energy monitoring for campus can be integrated. Attendance analytics, log-based anomaly detection. So this gives students not only the theoretical grounding but also exposure to industry-relevant paradigms, right, and understand how streaming operates as a whole. So key summary and takeaways here is that data streaming is a core paradigm for modern systems, right? It has emerged as a kind of a de facto standard now. So alongside databases and operating systems for building modern low latency event driven systems, Kafka kind of platform provides a durable, scalable, and decoupled log of events. Okay, and that serves as a central nervous system for the data. And Flink builds on top of this kind of platforms to deliver powerful stream processing, and it gives a broader ecosystem, basically to work with streaming first analytics, lakehouse, SQL on streams, event driven microservices, etc. Right, and real time machine learning integrations are also reshaping the system design. So overall, if you see, okay, basically streaming has become a de facto standard in industry given data is in motion, and we all need to catch up with this paradigm and understand how we can take it forward. Here are some references that I captured for you all. These are not the ultimate references, but few of them to start with, right? And these are one of the powerful references available in the industry today. I strongly recommend reading Kafka, the Definitive Guide. Whoever is interested to understand how streaming platform like Kafka is implemented, and designing event-driven systems is also another interesting read that can actually take it forward. Okay, so with this, I think we are done. We are open for question answers, and I would love to open the floor for questions and discussions, especially about how this maps to your existing courses, right? A useful closing question could be here, which course in your department is best positioned to introduce data streaming concepts first, if it is not already done? And then, we could also imagine how a hands-on workshop could be done where faculty and students experiment together, how Kafka and Flink kind of pipeline can be set up. You can actually think of small working groups designed and focused on this pilot modules to establish that streaming as a paradigm in our college, and then enable students to start thinking about it. So thank you for your kind attention. It has been a long session, but I tried to cover everything at my best and hope it was fruitful and it was helpful to all of you. Over to you, Dange sir.
Yeah. Thank you, Srenik sir, for this wonderful and informative session on data streaming. So now I request participants, if you have any doubt, any queries, so you can ask. You can unmute, or even in chat also you can put your queries.
So Dange sir, by the time somebody asks question, okay,
Yeah.
have we introduced data streaming as a subject in any of the courses so far?
As actually means part of Apache Flink and like Apache Spark and all those things that we added as a part of high performance computing course as one of the unit, but it is an introductory level, so just an architecture and all those things as we are adding.
Okay.
Yeah.
And I'm very much curious to know, okay, looking at today's presentation, what does faculty think? Okay, can this be introduced as a small subject inside your one of the subjects, or this itself qualifies to become a big subject, maybe an elective as well?
Yes, sir.
Yes,
Hello.
Muturaj sir.
Yes, sir. Yes, sir. Sir, thank you. Thank you. So this is data streaming is new to us. So we have planned to give this subject as an open elective for our students.
Okay.
One of the subjects, sir, not one unit or like that, one or two topics. So we have planned to give this data streaming as an one subject. So if we are going to implement that is one of our subject, so we need your more guidance related to this Kappa and Flinks.
Absolutely. Sure. I think I would be more than happy to share whatever I know, and definitely we can start shaping this up further for the benefit of students.
Yes, sir. Yes, sir. We are familiar with that. We know that how the video streaming is done, how the video stream, but data streaming it is completely new to us.
Right.
Yes.
It is an amazing subject in itself. And you know what? In industry, wherever you go, I can see insurance companies, banking companies. You just look at the LinkedIn, go to LinkedIn and search for the, data engineer kind of roles. Everybody is expecting you to know data streaming these days. The
Yes, sir.
moment you help students with this kind of subjects, it's definitely going to enable them a lot. And being an autonomous college kind of setup that we have, I would say we should be having a special, COE, Center of Excellence, which is focused on data streaming and which actually allows people to participate and learn on at their own pace.
Yes, sir.
So I see a couple of inputs coming from the chat. Dr. Rucha Samant has said it was really good, knowledgeable session with real life examples. It can be one subject as you explain its depth. Yes, agreed. And today, what we discussed, Dr. Rucha, this is just I would say we just made our feet wet in the water. Okay, the ocean is so deep that we all are going to have a lot of fun as a student of computer science, as a faculty, right? We will all enjoy this subject a lot. So yes, that's a good consideration.
Good
Another
evening, sir.
yes, Dr. Rucha.
Yeah, sir, I have done my PhD in the data streaming only, but today I attended your session from 7 to 9 and I couldn't, it was such a in-depth and from the beginning of the data to the data stream evolution, you explain in such a depth that it was just a wonderful session. Along with me, my daughter is sitting and she is also doing engineering. So she heard it and really total knowledgeable session. Hats off to you, sir.
Thank you, Dr. Rucha. I tried my best to cover up whatever I could and simplify it for all of you. So I'm glad that your daughter also, got benefited out of this. Very happy.
Thank you,
Okay,
sir.
I see another question from Mrs. Amruta Patil. What are the security concerns with respect to data streaming? Very nice question, Mrs. Patil. So what is happening is, as we discussed in the larger context, okay, producers and consumers are coming to this platform as a backbone of the organizations. So definitely all the security aspects comes over here, where this platform itself should be secure. So what is happening now, being cloud first approach adopted in the industry, everybody is putting their streaming backbone in the cloud. For example, you can run this in premises as well, but then again, I initially explained the concept of capital expenditure versus operational expenditure. These are the kind of decisions that weighs over here and forces companies to put their backbone in the cloud. Now imagine a streaming platform in the cloud, all the critical data are sourced into the cloud, and then it is lying over there. That means any breach happens into this kind of platform, it can actually cause a serious damage and information leak to the organization. So what happens is, this platform is secured from multiple angles. Okay, let's say from the transport perspective. Okay, basically we know TLS is becoming a de facto standard everywhere, right? So TLS 1.2, TLS 1.3 becomes a kind of a default transport layer security for everyone. Similarly, RBAC roles are there, which is going to give everybody desired access. Role based access controls are implemented. Now, similarly, when your producers and consumers are talking to this kind of systems, okay, then OAuth 2 is becoming kind of a de facto standard, where only short-lived tokens gives you access to produce and consume over there, and these are regularly refreshed. Even centralized SSO logins for organizations are becoming kind of a natural integration pattern for this kind of streaming platforms. And that's how the streaming dimension is, the security dimension is taken care of over here. I hope I'm answering your question. Okay, I see another inputs from people. Nice session, really excellent session. Thank you all. I appreciate that you were able to understand and follow up. It was a long session, and having your attention span for 2 hours, I was little worried, but then I decided that I have to cover what I have to write so that it helps everyone. Pretty helpful and brilliant session. Yeah, thank you, Sonali ji. Thank you, Gayatri ji. Thank you. So I see all the compliments. Thank you all for your help. And I see a feedback link from Dangesher. So please, everybody, feel free to share your feedback and give your valuable suggestions as well, so that whatever you felt it was missing here, we can cover it up for the next time.
Yeah, so thank you, Srenik sir, for this wonderful session on behalf of Department of Computer Engineering. we really thanks for your valuable time and accepting our invitation and ready for delivering this wonderful session. So once again, thank you.
I'm very happy. Thank you, sir, for this opportunity.
Yeah. So all the participants kindly give your feedback with this QR code. Scan this QR code and give your feedback. And one more announcement: tomorrow session is 2 to 5. And after the session, we have a validatory plus quiz will get conducted. So all should be available for that particular quiz, which is there at the end of the tomorrow session. So thank you all.
Thank you, sir.
Thank
Yeah,
you, sir. Thank you.
yeah, thank you. Bye.
Bye.